Okay, so we spent the last couple of days being able to graph systems of inequalities and determining solutions of those graphs. And then we've already spent a day doing this, but this is being able to do it with 2 lines where you have to be able to write the equations or inequalities from the graph, which is just the reverse. So we're just going to jump right in. So when we do this, we got to make sure we determine what the slope and the y-intercept of each line are. And as we go through this, I'm just going to label what each line would be. So for instance, number 1, we're going to label the solid line as A and the dashed line as B. Sorry, I wasn't done before the notes, but for that, letter A is where we're going to start. So we're going to do line A first. Since I know that it is a solid line, I'm going to use an equal to bar. Since the shading is above that line, I know it's going to be greater than or equal to. The slope of that line is used by finding 2 points, which in this case has a few. The slope of it would be 2 over 1, which simplifies to 2. But since the right arrow is pointed down, it's negative 2x. And the y-intercept would be positive 3. But then you have to be able to take that a step further and convert it to standard form. This doesn't have a fraction involved, so that means we can just move the x over, which makes it positive 2x plus y is greater than or equal to 3. And the only time that I need to flip this inequality when I'm going from slope-intercept form to standard is when I divided by negative, which in this case I didn't. Or also keep in mind that if the x is negative, that's essentially the same thing as dividing by that negative. But we'll see it when we see it. Let's do letter or line B now. So this time the line itself is a dash, so it will not have the equal bar. It is also shaded above that line, even though it's a little snip of a shading. So I know it's going to be greater than. And then the slope, which if I find 2 points, would be a slope of positive 4. And then the y-intercept of that line would be negative 3. Now this one, to convert it to slope-intercept or standard form, I apologize, is I got to subtract 4x, which is negative 4x plus y is greater than negative 3. Since the x is negative, I have to change all of these signs because standard form implies that the x is positive. But when I change all of the signs, I also have to flip the inequality because that's ultimately like multiplying everything by negative 1, which turns or flips the inequality. And there it is. So be prepared to write your inequalities in either slope-intercept form or standard. If we look at number 2, so this is where we would just identify which one. So I'm just going to label this one as A and this one as B. On your test, it's going to label them. So they're already labeled. But if I look at line A, the slope or the line itself is shaded above. So I know it's going to be greater than. Since it's solid, it's going to be equal to. The slope, if I identify 2 points, would be positive 5 or negative 5, sorry, because the right arrow is pointed down, and the y-intercept would be positive 3. To convert it to standard form, all I would need to do is add 5x, and since I'm adding 5x, the x would then be positive, which means I do not need to change the signs nor the inequality. If I look at line B, when it's a horizontal line, it has a 0 slope, but here's how I tell my kids. It's intersecting the y-axis at negative 2. It's a dashed line, which assumes that it's not an equal to bar, and it's shaded above, which would be greater than. Are you just turning in?
Yeah.
Oh. Now, the beauty of that one is, since it's in slope-intercept form here, it's identical in standard form. So there it is. If I look at number 3, so again, we're going to label this line A, this line B, no rhyme or reason. I just decided to do that right now. So if I look at line A, the line itself is solid, so I know it's going to be equal to. It's shaded above that line, even just by this little region, so it's greater than or equal to. The slope of that line would be 5 over 3, but negative since the right arrow is pointed down, and then the y-intercept would be negative 3. Now this one does have a slope or fraction for a slope, so we have to get rid of that fraction by multiplying everything by the denominator. In this case would be 3y is greater than or equal to negative 5x minus plus 9. That's wrong, minus 9. And then move over the x by adding 5x, which would then make it positive, which means I do not need to flip the inequality. There it is. If I look at line B, it's a vertical line, which signifies an undefined slope, but because it's crossing the x-axis, it's x something, it's crossing the x-axis at negative 3, and since it's shaded to the left of negative 3, that is less than. Since it's a solid line, it's going to be less than or equal to. And again, in slope-intercept form, they're identical. more practice for you. So if I look at this, I'm going to label this one A, this one B, just because. If I look at line A, the slope, or I'm sorry, it's a dashed line, which implies no equal to bar. The slope would then be negative 1/3. And since it's shaded above that dashed line, it would be greater than. The y-intercept would be positive 2. And just like number 3, I want to get rid of that fraction by multiplying by the denominator. So I have 3y is greater than negative 1x plus 6. Then I move the x over by adding, which makes it positive 1x, which then means I do not need to change the signs, and my standard form is there, which means I do not need to flip the inequality either. If I look at line B, it's a dashed line as well. It's shaded above that dashed line, so we're going to do greater than. The slope for this one would be 3/2. It is positive since the right arrow is pointed up. The y-intercept would be negative 3. The slope is a fraction, so I would multiply everything by the denominator. So 2y is greater than 3x minus 6. I would then move the x over by subtracting 3x. This time, because the x is negative, which in standard form the proper way is to have it as a positive, is to change all the signs, including flipping the inequality, because I'm ultimately multiplying by negative 1. If I look at number 5 on the back, just more practice here. It's line A, line B, gets pretty repetitive. For line A, it's going to be shaded below that dashed line, so it's just less than. The slope of that line would be positive 2x, and the y-intercept would be negative 1. All I need to do is convert by moving the x over, so it's going to be negative 2x plus y is less than negative 1. But since the x is negative, I do have to change all the signs, which then means I'm going to also flip the inequality. And there it is. Line B has a dashed line as well. It's shaded above that dashed line, so we're going to use greater than. The slope of that line is going to be negative x. Plus 2 is the y-intercept. Since it doesn't have a fraction to worry about, I'm just going to move the x over by adding x, which then makes it positive, which then means I do not need to change any of the signs, which means the inequality stays as is. And if I look at number 6, line A, it's a solid line and it's shaded above that solid line, so it's going to be greater than or equal to. The slope of that line would also be negative x, and the y-intercept would be positive 2. And just like the previous, all I need to do is add x to change it to standard form, but my inequality is different. I do not need to flip anything or change the signs because x is positive. If I look at line B, it is a solid line as well, also shaded above, so greater than or equal to. The slope of that line would be negative 4, since the right arrow is pointed down, and the y-intercept would be negative 1. All I need to do on this one is add 4x over there, and since it is a positive, I do not need to multiply by negative 1, which then does not change the signs nor flips the inequality. If I look at number 7, I already know off the bat that my inequalities are parallel, but that only specifies that the slopes are the same. If I still convert both of them, line A, it has a solid line shaded below, so less than or equal to. It has a slope of negative 1x and a y-intercept of positive 3. To convert it to standard form, all I would need to do is add x. And there it is. I don't need to change the signs because the x is positive. Line B, however, is a solid line shaded above, which would then just specify greater than or equal to. The slope is also negative 1x, which we said would be the case because they are parallel. And then the y-intercept is negative 3. Since the x is negative, I would add x to convert it to standard form. And then since it's positive after moving it over, I do not need to flip the inequalities. If I look at number 8, last but not least, I have line A, line B. Line A is saying this is the solid. Since it's a solid line shaded above, it's greater than or equal to. The slope of that line would be positive 1/3, and the y-intercept would be positive 3. To convert it to standard form, I would then need to get rid of the fraction by multiplying by the denominator. So I have 3y is greater than or equal to 1x plus 9. I then move the x over by subtracting 1x. But since the x ends up being negative after doing that, I need to change all of the signs, which means multiplying by negative 1. And since I multiplied by negative 1, I would then flip the inequality and change all the signs. Line B, it is a dashed line shaded above, so that's greater than. The slope of that line would be a little trickier here. 4 over 3, right arrow's pointed down, so negative 4 over 3x, and the y-intercept would be minus 2. Since the slope is a fraction, I'll multiply by the denominator, so 3y is greater than negative 4x minus 6. All I would need to do is add 4x over there, which would then make it positive, which then means I do not need to multiply by a negative 1 here. My x is already positive, which does not flip the inequality. You need to be prepared to write it in slope-intercept form and then convert it to standard, or just write it in slope-intercept form. Make sure you pay attention to whether it's a solid or dashed line and the shading region to determine if it's greater than or less than.